very important question. A bullet of mass 5 gram travels with the speed of 500 meter per second. If it penetrates a fixed target which offers a constant resistive force of 1000 newton to the motion of bullet, we have to calculate the initial kinetic energy of bullet, distance through which the bullet has penetrated before coming to rest, and speed with which bullet emerges out of the target if the target is of 0.5 meter thick. Now carefully see the question. Here we have a block, here we have a bullet. So bullet is moving with some speed, enter the block, reduces its speed, and it's come out with the less speed. As obvious, we have just seen in the movies also these types of things. When it is enter with more velocity, more energy, but this block is applying some resistive force on this bullet, so that's why when it is coming out its velocity gets reduced. So we have to just give the answer based on this question. So now first we have to calculate the initial kinetic energy. Before entering to the block, what is the initial kinetic energy of a bullet? So initial kinetic energy I have half m initial velocity square. Vi means initial velocity square. Okay, so half mass we have 5 gram converted into kilogram. So 5 gram, when I convert it into kilogram, it is 5 by 1000 kilogram, which is SI unit, 5 by 1000 kilogram. Now velocity, the bullet of mass 5 gram travels with the speed of 500 meter per second. So initial velocity we have 500 meter per second. Now put the value 500, okay, square. Now just calculate 500 into 500 two times. So here 1 2 3, 1 2 and 3. So when you will solve this, you will get 625 joule as a initial kinetic energy. Clear? So initial kinetic energy we got it as a 625 joule. Next we have to calculate the distance through which the bullet has penetrated before coming to rest. So this block is there which is actually decreasing the energy of a or decreasing the speed of the bullet. Now we have to calculate when the bullet will enter, how much is the distance traveled by the bullet before coming to rest. Before coming to rest means what? Carefully see. This block is applying some resistive force which is 1000 Newton, and means this block is decreasing their energy. How much there is decrease in energy? So if I'm talking about block, how much they are decreasing the energy, so this is force into displacement. So resisting force we have 1000 Newton, and displacement we have to calculate. Okay, means up to what distance this bullet will move, so that's its whole kinetic energy. Very important point, it whole kinetic energy is reduced to zero by this block. So this whole block energy is converted into kinetic energy, or vice versa, means this whole kinetic energy is taken by the block. So kinetic energy we have already calculated, that is 625 joule. Force is 1000 and displacement we have to calculate. So displacement we got it as 625 by 1000, that is 0.625 meter. Means up to the depth, or up to what distance this bullet will penetrate before coming to rest, that is 0.625 meter. Clear? Next we have the speed with which the bullet emerges out if it targets of 0.5 meter. Now the thickness of the block is only 0.5 meter. So initially the bullet is moving with energy, that is 625 joule. Finally it is coming out with some kinetic energy. Okay, final kinetic energy I don't know. So we have to calculate that energy. So where the another energy is wasted, another energy is taken by this block. How much this energy is taken by this block? So this energy is force into displacement. It means that if I'm talking about the conservation of energy, initial energy, we have initial kinetic energy, and this block is taking some energy, or I can say that block absorbs some energy, and after that it coming out with some final kinetic energy. Initial kinetic energy we have 625 joule. Block absorb how much energy? That is force into displacement. Force we have 1000, resistive force by this block 1000, and displacement, the thickness of the block is 0.5 meter. Final kinetic energy we have to calculate. So 625 minus 500, so final kinetic energy we got it as 125 joule. Clear? Now we have to calculate the velocity, final velocity. So final kinetic energy formula we have half m final velocity square. Okay, so here we have final kinetic energy as 125, 1 by 2, mass we have how much, 5 gram, which is 5 by 1000 kilogram into velocity square. Now just cross multiply, velocity square we got it as 250, this 125 multiplied to 250 divided by 5 and multiply by 1000. So here it is 50 taking the root, so 50, 5 into 4 zeros, 4 zeros coming out from the bracket, it become 100, and under root 5 is basically 2.236. So now multiply, so final velocity we got it as 223, that is 223.6 meter per second. So this is the final velocity with which the bullet comes out from the block. Clear?